Okay, sorry if you can hear lawnmower noise out the window. My neighbor's mowing the lawn, so I picked a great time to start this video. But that being said, we have here a original 19-inch Electrohome G07 out of an original Robotron. And this has not been removed from the machine in 42 years. This is the original G07 right out of the Robotron. You can see the Williams and stickers and stuff there and serial numbers and whatnot. This has not been touched or removed out of the machine in 42 years since it was put in there from the factory. And this is working, but it's having issues with the color red. I'm sure the solder joints are bad, or the solder joint for the header pin's bad. So I just went ahead and went to the arcade. This actually came out of the Robotron at the arcade. It was my partner's machine, and he got it from somebody, and he had it in his basement for years, and they just never had to mess with the monitor because it was always working. And it still works to this day, right now. I'm about to turn it on and show you. But the issue is that it's having some color issues from bad solder joints, and it's never been serviced. It's all original. I thought, you know what, let me just go ahead and put in a freshly rebuilt G07 complete monitor to get the machine back up and running, and then I'll bring this home and we will clean it and go through it and get it working. You can see, maybe you can get more light here, just how dirty this is. It has not been cleaned or removed or serviced or anything in 42 years. So yeah, we're going to do a complete total refurb. We're going to take the chassis out, clean it, reflow it, recap it, fix it all up just nice and good like we always do. We're going to take the tube outside, wash it, clean the frame, do everything that is required with that, so you can see how that's done, and the whole kit and caboodle. So I'm also going to do all this in real time, so get ready for a long video because I want you to see how long it takes to do something like this. So that being said, all of this stuff is original, but it's just coated in dirt and grime from 40 plus years of sitting in the machine. And we're going to go through and clean all this and get it brand spanking new. Get it looking brand spanking new. Anyway, the tube, even though it's 42 years old, is in very good shape. Minimal screen burn. It is nice and vibrant and bright, and it looks and works great. It just needs an overhaul, cleaning and overhaul. So yeah, the board, you really can't even, the board should be brown, but it's more like a, I'm not even sure how you would describe it. Let me just take my finger wipe across there. There you can see. So yeah, it's desperate need for some cleaning. So we're gonna get all that done, but first, before we tear it down, I thought, you know what, let's go ahead and fire it up so you can see this in action. And I actually want to do a little experiment here, see if I can just pluck these, this 250 volt 10 microfarad, this purple one here, and this other one right there, they like to leak. And I'll bet you anything, one of those, maybe both of them, I can actually just pull them right off the board. But just to show you here, this is working, so I'm going to actually flip this on. We got our trusty MK2 PCB here. We're all hooked up, ready to go. So let's turn this on. Yeah, comes right to life. And amazingly, 42 years later, it's still working. Unrestored, if you will. And of course, it does take a while to come on because it's an old tube, but once it fires up and works, it does look great, has a great picture. Of course, I need to adjust the vertical hold because it's never right. There we go. And colors might be off because this, like I say, this was in a Robotron, so yeah, you can see it works. Turn our brightness up slightly. And we're a bit too blue. Let's turn up our red a bit. Yeah, but hey, not bad. So it does work. Everything is great. So now that we know it works, we'll turn it off. And I don't think I've ever shown a discharge procedure here. There's dozens and dozens of videos on YouTube about discharging these monitors, but I don't think I've ever actually shown it, or if I have, it's very infrequently. So let's go ahead and discharge this. So I'm going to get a clip lead here on the alligator clip. Just clip it to my little adjustment screwdriver. Take the other clip lead, you can clip it to anywhere on the frame. I just go to one of the mounting screws right there, and we'll just take this and put it underneath the cup. Now, of course, do this at your own risk. This is not a video, well, I guess it is a video showing you how to do it. However, do this at your own risk, and you know, make sure you know what you're doing here. So because this can potentially kill you if you have health issues, underlying health issues or something. You know, it's 25,000 volts, give or take. It's going to zap you in the finger if you don't do this right. But, you know, get yourself a screwdriver, get your clip lead, clip it to the frame, clip it to your screwdriver, and make sure you're not touching any of the metal. And just slide this underneath the cap. You should hear that nice little zap. Oh, there you go. I don't know if you heard it, but a little pop. So that's now safely discharged. Then we can take the cap and just squeeze the two sides of it. And this should just come right off. Squeeze the two sides of it, and it should just come right off. It's not working because I wasn't squeezing it right. But you should be able to simply squeeze the sides in, but sometimes it doesn't work. Then, of course, you want to go ahead and try another discharge here. Okay, nothing came out of there, and it's good. So that's the easiest and quickest and simplest way to do that. That all being shown, I think it's time to go ahead and remove the rest of this thing here. It's very simple and easy. Now that we have the discharge complete, we can remove the CRT ground wire here from the neck. We can remove the neck board very gently. There we go. We can disconnect our yoke wires here. There we go. Disconnect our degauss connections. And our video signal as well, but all right, and I believe that's going to be it. Then we can remove our 2/4 inch fasteners down here on the side that you can't see. There's one there and there's one over there, so we'll get those out of here. All right, and then this should just come right out of here. There we have it. Let's take the tube and set it aside, and then we'll go over the chassis here real quick. All right, so there's a couple of things I wanted to look at here. Is we've got our, you know what, let me pause, get you on the overhead. All right, we're on the overhead, and I wanted to look at the video input header pins, and oh my God, they're dry. Good Lord. These guys right here, am I zoomed in too far? I can't tell here. No, that's fine, but the red is broken, which is the very first one, which should be this one. The red joint is cracked completely. There you go. So that one's cracked around there. I don't know if you can even see it there. That one's cracked. The sync pin over here is cracked. It's just all of this needs reflowed. So some of the points you want to hit on this when you reflow are obviously your video input header pins. There is a R902. The two joints here for this resistor get very thin and cracked. The yoke input header pins like to crack when they get thin. Various things like that. The main points are the vertical deflection ICs. There's two ICs here for your vertical deflection, R402 and X402 and X401. So these two right here, those like to get very thin, will develop collapse issues. Yeah, so those, your video input header pins, the R902 over here, your yoke header pins, and anything else that needs reflow. Those are the main points on the G07, but really anything else that needs reflow you want to hit. It's not like the K4900 that has, you know, AC jumpers that like to crack and break too, to keep it from powering on at all. So, yeah, it does look like there's some flux here and some flux here, but the caps have not been replaced. They're just as filthy and dirty and original as the other ones, so I'm 100% positive that they haven't been replaced. So And those are not two that normally fail that you'd replace anyway. So just out of curiosity here, I want to see if I can pluck these off, because on every G07 I've ever worked on, this 250 volt 10 microfarad and this 250 volt 10 microfarad just like to corrode and leak. And I wonder if I could just, we know it's working, so I wonder if I could just not really. So this one's somewhat intact, which makes sense because it's working. But yeah, so that one's okay. I was gonna say the solder joints are broken, but it's actually not. It's just loose. How about this one? No, it's good too. Huh. Well, everyone I ever worked on except this one. That would explain why it's working. But this one, I think I may have broken the joint or loosened it out of the hole, but it's fine. Anyway, so there's the chassis. So I think the first thing we're going to do is go out and clean the tube and show you how to do that before we get cracking on the main chassis here, because I need to give it time to let the tube dry and the chassis dry before we really do anything with it. So let's go out and wash the tube first. And the neighbor's mowing the lawn and it's kind of windy, so I think I'll just wash it in real time and do a voiceover. Add that post in editing. But I'm going to grab some Simple Green. I'm going to grab a brush here to agitate all of the dirt on the tube with the hose outside, and we'll get it all washed down and see how that goes. Okay, so here we are out on the little sidewalk next to the house. I'm sorry you guys see my big ugly feet here, but I didn't want to get my shoes all soaked from doing this, because this water does kind of splash around a bit and get everywhere, and I didn't want to get, I don't have any shoes that are junk, if you will, and so I just wanted to not have to worry about that. So sorry you have to see my big ugly feet, but we're just giving this a nice good rinse down with the water from the tap, and we'll spray it down once I open it up there. We'll spray it down with some Simple Green, get it all nice and coated there. We coat the yoke and the neck and the top of the tube. I didn't do the sides of the tube, but I did wipe them down later on, so not a big deal. The frame. And, you know, if you do this properly, you can save all of the stickers and the decals. You know, if they get wet, that's fine, but you don't want to use like an abrasive rough towel or something. You just want to use a nice little soft bristle brush there. I have a 1-inch soft bristle brush. Bristle? 1-inch soft bristle brush, easy for me to say. Just going around here and kind of painting all the dirt off, and get down here in the sides and the grooves, the insides of the frame, and underneath, and all the decals, and just, you know, all the common sense stuff that you'd think you'd need to do. And I hear a lot of people say, hey, you know, if I get water on the tube, isn't it going to get inside the tube, inside the anode hole? Well, no, the tube is under vacuum. And of course, most of the people watching this are going to understand that, but there are the novices out there who don't understand that the tube is under vacuum and it's completely sealed. So there's no way you can get water inside the tube, and if you can and you do, then your tube isn't going to work at all anyway. So no, you're not going to get any water inside the tube. There's no danger of getting water inside the tube in the anode hole. It's all nice sealed enclosure, nothing really to worry about there. So you can see there I was cleaning up the harnesses and the yoke cable and the connectors and all that stuff, and I even get underneath the bottom of the tube down there where you can't normally see, you know, and it's all common sense stuff. Wipe it down. And then when you're done, rinse it off and let it dry, and that's about all you really have to do. So you don't want to use any type of towel or big giant brush or something, because you'll damage all of your decals and stickers, and it's nice to be able to have those stay intact when you're done here. So yep, just doing everything I did on the top, on the bottom. Now we're wiping off, brushing off the yoke itself and the assembly and the rings and the actual glass part and all that stuff. Then we just give it a good rinse, and that's really all you have to do. It's not rocket science and doesn't take much. Just a nice little rinse here, and and of course you're going to have to wash your towel, because the towels are going to be soaked down in Simple Green. Wring it out, wash it. I mean, I'd wash it by itself, or other towels. You wouldn't want to wash it with your clothes in case there's something in the Simple Green that you don't want to get on your clothes. But yeah, when you're done there, you can toss that in the washing machine. You'll be fine after you rinse it out, of course. But yep, and just a good rinse, and we'll put it back down on its normal bottom there on the frame, and rinse off the top, and you end up with a nice squeaky clean monitor, brand new for the most part. And there is some stubborn dirt that takes a little bit more effort to get off, but it's not a contest. You're not trying to win any beauty pageants with this. It's just to get it clean, make it look good, and that's all there is to it. A little bit more pressure here on rinsing this off. And you're not, you use that soft bristle brush, you're not going to hurt or damage anything. And see, even after all that stuff, all those decals and stickers are still intact. So no big deal. And it was kind of hard to keep the camera steady with the wind going on out there. But now you can see I'm using this thing called a Pro Blow air blower thing. I use this for when I detail my cars. It gets the water out of the window sills and inside the mirrors and all the stuff where the water likes to hide and the emblems and things. And I'm using this to get rid of all of the water that's standing in the, on the tube. Because if you just let it sit there and air dry, you'll have streaks and you'll see where the water was and stuff. And you want to use this thing to get all of the water that is all the water you possibly can out of the yoke assembly and the neck and things like that. You don't want that water to sit down inside the yoke and corrode the windings. You want to lay it down on its face and use this thing, use gravity to your advantage, and then get this thing out and just blow all of the water. I think later on when we wash the chassis, I'm going to show you the part number and the model number and everything of this Pro blower that I'm using here. And yeah, it's not compressed air. Obviously, it plugs in the outlet, but it's nice, good stream of air, very powerful. And we can use this to get rid of all of the standing water on the tube and all of the water out from inside the yoke. And yeah, and like I say, you store it like this overnight while you're waiting your 24 hours, and all of that, use gravity to your advantage, and all that water will seep out and it won't sit inside the neck. Inside the yoke and corrode the windings. That's the last thing you want. So if you do this properly, you never have anything to worry about, and it'll work out just fine for you. So that's what we're doing here, and getting all the crevices and nooks and crannies, and I think that's about it. Yeah, we'll set it back on its bottom there, and I think I spray off the face here too, if I'm not mistaken, but a little bit more, underneath the implosion band. Anywhere, to give it a good, 2 or 3 minutes. Just go around, and yeah, that's the face. Just use the air, blow it all off, and then we'll let it air dry, and that's it. All right, so the tube is now nice and clean, and I highly recommend setting it up on a towel or something. We're just here in the garage. I'm going to leave it out here for 24 hours so it can be in the heat out here and dry everything sufficiently before we try and power it up 24 hours from now, for me anyway. But I highly recommend laying a towel out, setting it down on its face, so any remaining water that's inside the yoke will drain out this way and not sit inside the yoke and corrode. You don't want that. So yeah, and then of course you saw I was using a little blower, which I talked about in the narration, which I'm sure I did. If I'm smart, I talked about it in the narration, to blow all that water out that I could. And then once I got everything out and I stopped seeing water come out, I brought it back here into the garage and set it down on its face here, for any water that was trapped in there will drain out this way, and it should be good to go. So now let's go in and wash the chassis and proceed from there. Well, here we are in the deep sink with the G07. Now, it's very important. I should say, actually, I already removed the cardboard backing from the neck board. That never lines up with anything, but it's very important. You do not want to directly douse or soak the neck socket on the neck board, because if water gets down inside of here, inside of the focus plates, they will corrode, and you'll never have a functioning neck socket again. You'll never have a functioning focus option again. So you do not want to soak the neck board. So I like to just clean the neck board with some alcohol and my brush here afterwards. So when we wash this thing, we want to make sure that we are very vigilant, is what I meant to say there, and we do not get the neck board wet. So it's going to be a little difficult. So we're going to disconnect the connector here off of the main board, which goes right there. You saw me just disconnect it. And we're going to try and hold it up out of our way while we clean this off. So I've already got the water heated up, and I like to use this Dawn Power Wash Platinum Plus thing to agitate all the dirt So we are going to wash this down and see how good this turns out. So let's turn on the hot water. All right, and we'll start rinsing it off here. Okay, now we'll turn the water off, and we're going to use the detergent here to just coat liberally. You don't need a whole bunch of it, just enough to kind of whitewash the board here, and the cables, and the anode cup, and these cables here, the focus block behind back in the crevices. That's about all you're going to need. Okay, now we can just go to town agitating this here. And you guys are going to be just blown away by how good this looks after we're done here. It's going to be truly unbelievable. Now we're going to use the same procedure with that blower that I used for the monitor, the actual tube, because you want to get rid of all of the standing water. If you don't have one of those, you can actually just use some isopropyl alcohol, douse the board in isopropyl alcohol, and that'll disperse all the water. You can also use WD-40. If you're not aware, the WD in WD-40 stands for water displacement. So if you have any WD-40, you can just spray that all over the board, and that'll disperse all the water and keep this from, you know, corroding up on you, things like that. And of course, letting it sit for 24 hours is somewhat key and crucial, you know, especially if you don't have one of those blowers and you use the WD-40 or the alcohol option. You want to let it sit for at least 24 hours before you try and power it up. Otherwise, you could obviously short something out. So let's get down in here, get down in here, get down in here, get down in here. We just want to clean our chassis. And it's probably not going to be perfect, but it's going to look immensely better. And you want to be aware, you don't want to scrub too hard or too deep or too with that much vigor, because you could damage, you could whack a component, a passive component, and break a solder joint, and then be chasing your tail forever trying to figure out what you did. That's why it's always important to test it beforehand, so you know if it doesn't work afterward, it's something that you did. So, okay, I think that's going to be good for that. Let's fire the water back up. And I think for this, let's set this up like so and rinse it off like that. Probably going to be the best way here. All right. Stay there, you. All right. And doing this all gently also helps keep your decals and stickers intact. They won't always survive, but there's a better chance of them surviving if you're a bit gentle with the brush. We're going to have to go through and hand wipe and hand clean some of this stuff, but okay, I think that's a good enough rinse. For the cables and such, we're going to have to go through with a towel and rag and clean this off with a rag, but for the most part, yeah, we're going to have to do that with some of this stuff. But the main board that we can't do that on is now wiped down. Let's rinse the back side off, get rid of some of the bubbles on the back here. Okay, of course you want to use hot water, the hotter the better. So I'm going to go grab my little blower device. We're going to blow off all this water and proceed from there. Hang on one second. Okay, so this thing is a Pro Blow model Echo Quebec Papa 403. If you want to use this, that's what it is. So it's also loud as hell, and I'm not going to take it anymore. But I'll probably just lower the volume here while I'm running this thing. But yeah, here's how it goes. So here we go. Okay, so again, you just want to use that thing until the board is visually dry and you don't see any water being blown around anywhere. Once it's visibly dry and you don't see any more water flowing around or moving around underneath stuff, get down in the crevices and cracks and underneath, you know, things like the degauss, what's that called, thermistor, and things like that, underneath the horizontal drive transformer, underneath the flyback. Get that air flowing everywhere and around, blowing out from inside the horizontal width coil, all that stuff. Once you don't see any more water flowing or coming out from underneath stuff and the board is visually dry, then you're good. You can let it sit for 24 hours or do your work and then come back 24 hours later after that, or however long it takes you or whatever, and then fire it up, see what you get. So let's go take a look a little bit closer on the overhead and see how good this turned out. Okay, so here we are, and let's just take a look at how well this turned out. And you can see how this procedure ends up if you would like to try it yourself. So, you know, there are some areas like this, you're just not going to be able to clean that off because there's like a coating. It's like a coating that you have to scrape off, and a brush isn't going to do it. You can see there I used my fingernail. It's like this coating that's on there, and you have to like take an actual you know, not a Brillo pad, but like a Scotch-Brite pad to get rid of all that. And you would have to remove all the components, all the heat sinks, and we're not going to go through all that. Our job here was just to get rid of all the surface dirt. And as you can see, we have done that. So compared to how it was before, it's pretty good. And that's all we're after here. It doesn't need to be completely spotless. Like, you know, you don't have to go to full 9 and get rid of this rust. We could, but no real reason to. We're going to, when we cap this, we're going to take this little RF shield and throw it away. We don't even need it. It's not necessary. So you may say to yourself, hey, what about, you know, RF interference and oscillation issues? Don't worry about that. So, yeah, it turned out real nice. Flyback's nice and clean. So that's the procedure on how I do all this stuff. And you can take it upon yourself to get rid of all this coating if you want. I don't bother with it. So, and unbelievably, the original factory width coil is still intact. 42 years. Might be the first G07 I've ever seen that doesn't have a burned up, broken horizontal width coil or a frozen plug. So, kudos there. All right. Now, what do we do about the neck board? Well, let me show you here. First thing we're going to do is get a little alcohol on a paper towel here. We're going to clean off these cables. Now, this flyback might fail at 5 minutes after I get this rebuilt, but for the sake of assuming that it's not, we're going to go ahead and clean it. Okay, good enough. Inside here, I forgot to blow this out with the water. Alright, that's fine. Okay. Now, the focus wire, which is absolutely filthy. How well will this work? Pretty well. Not too bad, not too bad. There we go. Okay, so the neck board. How do we clean this? Well, again, we'll get a little alcohol here and put a towel down, a futile maneuver.
A futile maneuver.
But we'll put it on there. And grab our here it is. I set it down. I knew I set it down. The question is, where'd it go? And we'll just clean this off with some alcohol. It's not going to be as good as the main board, but like I say, you don't want to get any water down in this neck socket. Avoid at all costs, because you can't really blow it all out. So let's clean off our brush here and try to do a little bit of cleaning on here. Okay, now that we've agitated all the dirt, and the back of this neck board is super fluxy because it's my fingers are sticking to it. That alcohol has freed up all of this leftover flux on the back and my fingers are sticking to the board. But I think that's pretty good for cleaning up that neck socket. Anyway, so there we go. Now let's throw a little bit more alcohol on here and let that kind of air dry. Give it another little quick whisk.
I'm just gonna give them one quick whisk here.
And then we'll just let that air dry here for a moment. Look at the rag here. It's turned yellow. It's turned yellow from the flux on the back of this board that the alcohol is removing. Oh, even my little spots here are turning yellow, or the alcohol as it comes off the board is turning yellow. Wow, that is a lot of factory flux on the back of this thing. Alright, so we'll let that, actually, you know what, let's put my actual rag down here. We'll do it that way. And while that's going down, let's clean off this connector, or this harness. Now I talked about how this gives you an idea of how long it takes to do something like this in real time, but obviously it'd be a lot faster if I wasn't having to make a video and do a narration and stuff and describe things. But just take that with a grain of salt and assume that you're going to end up having to do this yourself at roughly the same rate as what you see in the video. So yeah, I think that's going to work out. We'll just let that air dry there. And okay. In the meantime, let's grab a cap kit. I said real time, so I'm not going to cut away here while I dig through my cap kit box. Okay, 2000 polos. Ta-da! Okie dokie, Smokey. The iron is on, so we can go about this. Now, I'm not going to change the filter cap because there was no reason to. It was functioning, it was working. I'm not going to change the filter cap. I only change these out if there's a reason to. And then, of course, we're going to get our B+ set, do our light bulb test and everything after we do the cap kit, because things will change and readings change and things like that. And I do want to mention that recently I had one of these that I hooked up and it ran and worked. It had good B+, it was right on 120. I had raster lines, I had good raster, I had, you turn up the focus knob, and I got a bright screen, I got the raster lines, but I had no video. I had my setup here on the bench running. I knew there wasn't a problem with the video, I knew there wasn't a problem with power supply or PCB, and I had a working chassis, but I had no video. And it turns out that the X304 and X303 transistors right here were actually shorted. These two transistors here were dead short, and I changed them out and I got my video back. So if you ever have a G07 where you have raster and the raster lines and it works and operates, but you have no video input, check to make sure X303, X304 aren't shorted. One of the two or both. Just putting that out there. Okay, so let's just start with our cap kit. So we will take out, I guess our first one here is we'll do this 250 volt 10 here. And here's my process. I just heat up the pads and the cap comes right out. So I'll zoom in here a bit so you can see. But right here, if I just heat up this one and rock the cap out towards me this way, heat up this one, rock the cap the other way, 2 seconds, it's out. And actually, it's not leaking at all. That's amazing. Can't say I've ever seen that before. Or, that particular cap, these two purple 250 volt 10s, I can't say I've ever seen those not leak before. It's very rare, I guess. So we just tap the hole there, tap the hole there with this Chemwick number 4 braid, and we are ready to put in our first cap, lickety split, just like that. So I'm going to dump these out. I just dump them out into a pile. Like that, and it's very easy to just go ahead and grab one at a time that you need. And I've done so many of these, I know what caps are what, just from the size. So we've got a 250 volt 10 here, which is one of these two. And I just hold on to the leads and whoop, it pulls right out. You don't got to spend time cutting it out, peeling that tape off, it just pops right out. So we will put this in here. Make sure you line up your dot with your negative, but this one here is backwards. We'll get to the, well, let me see. It's this one here, C302, is silkscreened backwards, so you can see that the negative is actually on this side. So the negative should be on this side when you flip it over, but you can see that it's actually silkscreen positive on this side. So C302 is actually a silkscreen backwards on the bottom. So don't go off the bottom for the cap. Always take a look and see, okay, before I pull this cap out, take a mental note. To avoid issues like that, don't ever trust the silkscreen on either the top or the bottom of the board. If the chassis is working, take a mental note. Okay, when I pull this cap out, negative goes this way. Then you'll never mess it up. But I've done so many of these, I know what the pitfalls are. So I'm going to zoom in here for the solder up close, and then I'll just go ahead and do the whole kit. So you can see how I take them out. You'll be able to see how I put them in, and then you can watch as I do all the rest of them. So once we get that one in, a nice fat dime, we'll reach under here and I'll push on the top of the cap so it sits flat. There we go, it's nice and flat. You want these to sit as flat on the board as possible to prevent them from wiggling and moving around and coming out of the cap, the legs that is. And there you go, 2 nice fat dimes. 2 nice fat dimes there. So we will snip these off with a pair of Play-Doh, my little yellow friend.
Play-Doh, my little yellow friend, I'm here.
Clippers right here. And there's one down. So I'm going to go through here just kind of in real time. Maybe I'll put a little music to it, I don't know, but we're not going to speed up the video. And our neck board is now dry and it's nice and clean as well. So, neck board drying. Your neck board is now dry. But first we'll mark this. Now, I've had people ask me why I mark these. That's just so I can grab it at a glance and see, okay, it's been capped, or the next person down the line that has this for me, if you put it back in a machine and 5 years from now we sell the machine, the person can look in here and say, okay, it's been capped, just as a reference of it actually being worked on is what that's for. So that's why I do that. So that one's done. We had a couple of fat dimes. Let's go ahead and do the one next to it. And again, I just heat up one leg, rock it towards me, other leg, rock it away, and it's out. Done. You don't need to use any fancy desoldering equipment or anything like that, or fancy solder suckers. Just get yourself some braid, do that technique, and you'll see how look how quickly this works. This is all you have to do. People make too much of this. It's very easy. So we will just tap our braid real quick like this. Boop, and boop. And there you go. 2 open holes, 1 second. It took 1 second for that to happen. So it's just that easy. You don't have to make a big deal of this. All right, so now 63 volt 47. That's a 4.7. Don't fall into that trap. This is a 4.7. I'm not even sure if there's any 47s in this kit. There might be one. No, I don't even think there is a 47 in this kit. So it's a 4.7, and that is here. And again, you just kind of hold on to the legs, and you can pull it right out. And then, of course, if you have some tape left over, just pull it off. But all right, and we'll put this in the way it's supposed to go, just like so. And you want to make sure that this is, you can't put this one flat on the board, so just make sure it's sitting upright and not kind of bent over to the side. So we'll get a little solder on the tip of our iron and just kind of tack it in place like that. And then we'll turn it over, make sure it's sitting flat, or not flat, but it's not bent over. It's bent over, so make sure it's nice and upright, just like so. Then we'll go ahead and hit the other side. And you want to leave a little bit of time. If you heat up one leg and go immediately to the other one, the cap can fall out. So leave yourself a little bit of time in between those, and a couple more nice fat dimes on there. So you see there how to do that is you want to put the heat on the pad. you want to put the iron on the pad and introduce the solder to the joint. You don't want to try and put the solder on the pad, then introduce heat. You want to put the iron on the pad, introduce heat up the pad, and then add your solder, and that's the best way to do that, assuming you have a good iron. I run mine at 800 degrees Fahrenheit, which makes quick work of something like this. And you don't want to fall in the trap of giving yourself cold or bad solder joints. Alright, so I think I'm just going to cue the music, and you guys can watch. Anything that I see, I will report. Otherwise, you can just watch the method here. And of course, again, make sure you don't put C302 in backwards. So, yeah. Alright, here we go. Alright, so it's all done. Unfortunately, when I was moving it around, I made a comment about how awesome it is to have this still intact, and I whacked it with my hand, and the freaking thing broke off. Well, I'm going to try to glue it in place. I don't imagine that it's going to be a permanent fix, but I'm going to try to glue it in place here. So I'm not going to hit the you know what? I think we'll wait. I think we'll wait until we're all done. Let's wait till we're completely done, where I can set this overnight, and then when we go to work on this, you know, tomorrow after everything is dried and the tube is ready to test and things, then I'll glue it back on there. So, but there you go. Full cap kit complete. It didn't take very long. I don't even know how long it took. Less than. Oh, we got. See, this is why you let it. This is why you let it sit right there. See, I got some water coming out from the horizontal drive transformer that took a while for it to pop out of there. So that's why you have to let these things sit, because you may think you've got all the water out and you don't. So yeah, even with that air blower, there's still water trapped in the case here for this drive transformer, and I don't think that I can remove it because it's plastic glued in, or plastic welded in. Yeah, I'm not going to bother. Well, I don't know. Let's see. Can I get the case off? I think it's plastic welded in, quite honestly. Yeah, I think it's glued in place on the inside. Pull the whole transformer out, but it's fine. So we'll spray some alcohol down in there. There we go. That should be good. And that'll dry up and we'll be fine. So, all right. Next up is our reflow. And that'll be about it, because we know it's functional. So with the cap kit complete, let's talk about reflow. So again, the key points you want to hit are R902, these two joints there, our video input header pins right here, and of course your sync pins, your yoke pins over here, and your two vertical transistors. And then anything else that those are the ones you want to hit. And then you want to go through and look at anything else that even remotely needs it, hit that too. So that's what we're going to do. So we will start with F902 or R902, which are these two guys here. They get very thin and you develop power issues. I'm actually going to put a bridge across here for those, so that shouldn't be a problem anymore in the future. Can't really do much about that one over here, but that's fine. Let's take a look at the anchor points for our filter cap are a little anemic, but you don't have to do that, but I do anyway. Okay, anything else? Degauss connection, we'll hit that one. C901, we'll just hit that one. These diodes here, R901 is our thermistor for our degauss coil, and that was severely anemic, very close to breaking or cracking. We'll just hit all these points here. Again, you don't have to do this. This is just like a preventive measure. And you don't want to push too hard with the iron. You'll pop the leg of the component out if it's not bent over on you. So, all right. We'll go ahead and hit these connections here. And anything else in the video generation circuit, that all seems okay. So let's just go ahead and hit our input header pins here. Man, those are the sync pin over here and the red are just completely cracked. Those may be the thinnest joints I've seen on one of these in a long time. And another reason why you want to wait 24 hours before you fire this up after doing the wash is the water and the liquid likes to hide out underneath the filter cap and the flyback. So when you go to reflow the filter cap, you'll hear a hissing sound, and that's the water evaporating. So you want to make sure you wait, give it some time. You don't want to create problems for yourself. So, all right, anything over here? Let's take a look. We'll hit our B+ pot. And okay, that all seems fine. Let's move on to down here. This. I'm just going through and hitting anything that looks fairly thin. They all look okay, and nothing is cracked or broken, but you can hear that sizzling. Maybe you couldn't. There was moisture trapped right here, and it was sizzling on me. Now you can see this whole area here where that alcohol came through. I have to clean that up. We'll get that taken care of when we do our flux removal. So this resistor here, that one. Anything else? This is pretty dry. The other side's fine. This capacitor down here. This resistor. D504 looks pretty dry. R525. D507. R516. R520. R414. Okay, so now let's hit our X402, our vertical transistor, and X401, our other vertical transistor. Those actually looked okay, but we're going to hit them anyway, as you always want to. Anything else over here? We can go ahead and hit this resistor, R528. And be aware of any bridges you might create by doing this. Keep an eye on what you're doing. All of our adjustment pots look okay. Let's hit the yoke pins. That one looks fine. This one's pretty thin. That one's fine. This one's pretty thin too, so we'll hit that one. Alright, D506 is looking haggard. We'll hit that. Okay, that's not bad. I think that will do for now. So, let's clean up all of our mess here. And how I do this is I just get my microfiber towel, an old toothbrush, and we will just simply coat this. I'm going to turn my fan the other way so I don't dry my alcohol out. I actually use denatured alcohol because it doesn't evaporate as fast and it cleans better than isopropyl, in my opinion. So we just coat this and scrub it down. And we'll just do about half the board at a time. Clean off the brush and just kind of dab on here. You don't want to scrape and wipe, just kind of dab, and that will suffice just fine. And then we'll go ahead and just do another light coat here and Okay, clean off our brush. Do a nice little dab. Okay, and you'll see that it dries with kind of like this white film on it. It's hard to really see on camera, but we're going to go through here with our wiped off brush and just kind of hit it without any alcohol on the brush. And there you go. Not perfect, but that's about good enough for government work, as they say. So now we have a good G07 rebuilt, ready to go. Of course, the flyback could explode 5 minutes after we turn it on, but that's, you know, like any monitor. And these have a reputation of exploding the factory flyback after capping it. So a lot of people will insist that you change the flyback whenever you do a cap kit on these. Well, I highly disagree. I used to be of that mindset, but not anymore, because I'm of the mindset that if it's working, you don't need to replace working parts. So if you fire it up after your cap kit and the flyback explodes or snaps in half 5 minutes after you turn it on, then change the flyback. But if it's working, don't change it. I do not like changing parts just for the sake of changing parts, because there's no guarantee that the replacement parts you put in there will be as reliable or work as well as this one is. So yeah, don't change the part just for the sake of changing parts. So I'm not going to put this RF shield back in. If you don't like it, I'm sorry. I'm going to take it and throw it in the garbage. There it goes. So all that's left here, oh, I forgot to mention, I did break the joints a bit. They were still intact here. Oh, we forgot to clean the neck board. They were intact, but the pads were lifted, so I went ahead and just as a precautionary measure in the future, so this won't get loose and finally break the pads off, I went ahead and just did a little scraping there and soldered to the exposed traces, so it's nice and secure now. So I did damage that, but it wasn't, they were still intact, but it was loose, so not loose anymore. I forgot to clean the neck board here. So same procedure. We'll spray some alcohol on here, just coat it, and then we'll go to town with a little scrub. This thing had a crap ton of flux on it, so it may take a few attempts here. Clean the brush off. Do a little wipe and dab. One more time. And we also forgot to check it for reflow needs. So, okay, that is looking good. So, is there anything on here we need to reflow? Some of these like to get very thin and break on our neck socket, like, oh, right there, focus. I'll give you an example here. A lot of these like to do what you're about to see. So right here on our focus pin for the socket, you'll see here that it's cracked. Maybe not so well, but yeah, a lot of these look like that. All these ones around here look like that. So we're going to reflow those, and that really should all be what we should need to have to do. That's an odd sentence to say. That should be all we need to do. How about that? So we'll reflow that. I can hear some hissing. And I think that's probably the alcohol as opposed to water, but yep, every one of these is making a hissing sound from, yep. Let's see if you can hear it. I'll try and get this up to the camera here. I don't know if you can listen, but maybe you'll hear it here. I'm not sure if you could hear it, but they were all hissing. So, anything else we need here? Let's take a look. Let's hit our color resistors here. These resistors for the color drive get a little hot. Well, they get a lot hot. and the joints like to get dry on these. But traditionally speaking, they don't really crack, but they looked pretty dry and thin, so these resistors there. Anything else? Color drive transformers. Nope, those all look okay. All right, so we are now complete, and it's time to wait 24 hours, and we'll come back tomorrow. I mean, I can't even do my light bulb test until the water dries out from underneath the filter cap for our B+ test. So, all right, well, there it is. We'll let it sit for 24 hours. I'll come back, and we'll be ready to test it, make sure our B+ is good, make sure our light bulb test works. Let's take our pot and clean it and set it to 120. You know, we can go ahead and clean it now, I guess. How I do is I get this electro contact cleaner, or QD contact cleaner, and I spray the pot down and just wipe it back and forth like this. These pots sit in one spot for years and years and years, and the carbon contacts develop oxidation, and you'll get bad readings. So we're going to go through and do that on all these, and just put them back roughly where they were. And this stuff evaporates pretty quick, like even quicker than the alcohol. All right, that's close enough. All right, so we'll go ahead and just do this. And this stuff doesn't turn the board white like the alcohol does. This stuff just evaporates, and you don't really got to worry about anything. So, okay, let's call it good for now. Come back 24 hours later and see what it looks like. Well, we know what it's going to look like. Let's wait and see how it turns out here. Okay, so it's 24 hours later, actually officially 22 hours, but only a few moments from your perspective. And shortly after I cut the video off just a few moments ago, I went ahead and did glue the top of the H-width coil plastic piece back in place. It is nice and super secure. I didn't get any of the glue in the threads, so the core is able to go all the way down and back out with no problem. So that's repaired. And I also hooked up the RGB signal wires here from the main board to the neck board, which I have a tendency to forget to reconnect some stuff that's out of the norm of stuff you normally connect when you hook this up and turn it on. I have a tendency to forget the stuff out of the norm, so I went ahead and hooked this up while I had it on my mind, or otherwise I'd probably forget. And I also did, if you didn't fast forward through the end of the cap kit there just a few moments ago, I did the curl mod. So some of these are affected with a curl at the top of the screen. This one really didn't have that at all that I could see, but it's not a bad idea to go ahead and do the mod to kind of future-proof or prevent it from happening in the future on these. So it's really simple. The original cap in the C501 position, you take that out and just discard it. And then you take the C303 cap from that place or that spot and move it over to C501. So with C303 moved into 501 and the original C501 discarded, then you take a 50 volt 22 microfarad cap with the positive lead facing this way, put it in C303 spot, and that's the curl mod. So you know, that if you have an issue with one of these where the top is curling over a bit and you haven't done that mod, do that mod. That should somewhat take care of that. So with all that complete, we now have a fully rebuilt G07 cap kit, reflow, inspection, clean everything you'd normally do to these. Now again, I'm not going to change the filter cap because it's working. There's no need to unless you have a wave or something like that. So there's not any reason to change that. It's working. And like I say, I don't change parts just for the sake of changing parts. And the original flyback is still installed. Now, it could explode 5 minutes after we turn it on, but if it does, then we'll put a new one in. But as it stands now, it does work and operate, so I'm not going to replace it. So I've talked about all that already. Now, in the cleaning of this, we were able to actually still keep intact all of the original labels. This one's a bit washed away there on the edge, but we were able to keep all the original labels intact, even the one on the flyback. So if you're gentle with this, you can clean it and get the job done without sacrificing some of the little niceties, if you will. So now I want to do a light bulb test. Now I've already got a video on the light bulb test, but I figured, hey, why not? I did have to clean and wipe and move the B+ pot back and forth. So I want to put this somewhat closely back to around 120. And you see me using an actual metal screwdriver a lot for adjusting these pots. You shouldn't do that. Never do that. But the plastic tool that I have, the end is all messed up with, and I can't see, I can't turn the pot with this thing. And I have the other end here is actually metal, so there's no difference between that and this. So if you're wondering why I don't use plastic tools, well, that's because my official plastic tool is worn down to a nub and it doesn't turn the pots anymore. So I need to get some proper ones. But, you know, never use a metal one, but I'm going to use a metal one anyway. So the reason you don't want to use a metal one is because some of these pots, you can put the metal one in here and short the two contacts together, and then you zap your vertical section or something like that. But these pots traditionally don't have that problem. That's why I'm not, you know, I'm cautious, of course, but I'm not really too worried about using a metal driver on these particular pots, because if they go all the way through, it's not going to short anything out. But some pots, you do that, they'll short out to the frame if there's a metal piece behind it, then you're in a world of hurt. So just want to put that out there. Never use one of these. You'll see me do it, but never do it yourself. Okay, so how do we do a light bulb test on a G07? Well, it's very simple. You do not want, on the bench I should say, you do not want the horizontal drive section to fire up. How do we prevent the horizontal drive section from firing up? Well, you just have to remove one wire from the horizontal output transistor. Now, in a very, very layman's terms, a transistor is just a fancy switch. It turns things on, turns things off. So on the HOT here, there is a yellow wire that attaches to this leg of the HOT. You just simply remove that yellow wire, and that will prevent your horizontal section from turning on. You won't have to worry about your flyback generating high voltage, zapping you in the hand, or shorting out to your frame, whatever you want to call it. And we can simply, stupid holder for my irons falling apart. We simply heat up and remove the yellow wire off of the HOT. Leave it sit out in limbo like that. We'll zoom in a little bit far away. So I just took that wire off of that leg of the HOT there, and that's all you have to do to prevent the horizontal drive from firing up. Then we can take our 60-watt incandescent bulb, which is very close analog to the picture tube load on the chassis once it's working. We'll go to that leg of the B+ resistor. We'll clip the other leg onto the frame over here. Let's go around this way. We'll go on the frame over here. And this guy should light up, and we'll have to get the meter out and verify we're close to 120. 120 volts DC is what you want to have when you're doing this test. So let's grab a couple more leads here, and we'll clip this on as well. Clip this to the frame. There we go. Not actually in there. There it is. All right. So volts DC, and we're looking for about 120 volts. Might help if I plug this consarnate thing in here. Consarnate. Don't know where that word came from. Okay. I believe we are ready. So let me get my... There it is, 126. Not sure if you can see that. So we want to be down to 120. So if we just, a little bit goes a long way with adjusting this. So all I did was put my screwdriver in it, and it went to 123. So let's go down to 120 here. There we go, 120.76. Okay, good on that. Now, you know, it's tough to eyeball it. So also, when you when you power this up on the G07 specifically, you have to discharge the filter cap, or it will zap you quite harshly. But our light bulb can act. I don't know if I want to show this with a giant spark or just use the light bulb. Let's just use the light bulb. I don't want to darken or blacken the leads on the filter cap. So let me put this away here real quick. Okay, so we'll have to flip this over now. If we touch the two leads of the filter cap, the light bulb should kind of blink for a second. I'm going to turn the overhead light off. Maybe you'll be able to see here. Let's see what happens here. All right, so it's already discharged from having the light bulb hooked up during the test. But let's say there's a situation where you go to do this and your light bulb test, light bulb does not light up. Okay, well that's a problem. So what I'm going to do is I'm going to go ahead and make sure the HOT wire is not touching anything. It's not, okay. I'm going to turn this on without the light bulb hooked up. Here we go, 1, 2, 3. Okay, nothing happens because that light bulb isn't hooked up. So now we have just energized the filter cap. And if I touch that, that would shock the crap out of me. So you can either take a screwdriver and snap it across the two contacts and discharge it, but you'll blacken your PCB. Or you can simply take your light bulb, I'm going to turn the light back off here, and I'm going to touch the two leads, positive, negative, and watch what happens with the light bulb. It didn't work. What in the world? Okay, it's on right now. And I'm just going to touch here. Okay, see, it lights up. I'm going to turn it back off. Is this making a liar out of me? I don't know. Regardless if I'm lying or not, they always do this. If you turn this on without a load on it, like the light bulb, that will charge and it will zap you. But I don't understand. It might not be enough to make the light bulb. Yeah, it just might not be enough to make the light bulb light up. But you always want to discharge it. So touching that light bulb across there, absolutely discharge that filter cap. And we don't have to worry about getting zapped. So I just wanted to put that out there. Sorry it's not a great show and tell there, but you get the idea. If you don't have a light bulb, like I say, you can take your screwdriver and touch across the two leads here. What you'd want to do is just make sure that the positive lead touches the negative lead with your driver. And yeah, we got nothing there. So that's the alternate method if you don't have a light bulb or a way to discharge that through a load or something. So all right, so that pretty much takes care of everything. Now we can get this back on the tube and give it a try. And we'll get our wire back on here. Slide it right back over and done. Wait for it to cool down. Oh, I didn't wait for it to cool down. It gets hot. So we'll give it, you know, a number of seconds here. All right, that's back on there. Wait for it to cool down, then don't wait for it to cool down. Try and yank on it too quick. All right. So let's grab our picture tube, which I have already preemptively gone and got out of the garage. And we'll spin it around. And let's get the camera off the overhead, get this hooked up, and see what happens. All right. So we'll start by making sure everything is up out of our way, move our yoke wires out of the way, degauss wires. You want to kind of move these with some, be careful moving them, is what I should say, because the wires can break off the resistor terminals up there, and you got to resolder them on there, and it's a pain. So we'll set this in place and make sure that it's in the groove back there, and make sure it's sitting in here the correct way. And it seems secure, the holes are lined up, it's in the holder back there. That's all good. Let's get our screws that I put up here yesterday, from my perspective, just an hour or so ago from yours. I don't know how long this is going to end up being, but okay, then we just put the screws back in the frame here, and that's good. Now we'll hook it all back up. We'll start with our degauss. Run the degauss wires underneath the B+ resistor, underneath here like this. Don't set them on top of the B+ resistor, they'll burn them up. So kind of run them underneath the B+ resistor so they're down under here. It's hard to see, but down underneath the resistor right there. Then we can just hook these back up to the degauss connection. Degauss, however you want to say it. Okay, now we can grab our yoke wires and hook them back up to our yoke connection. Back on they are. Take our neck board. You want to hook up your anode. The very last connection is the anode, because if there's any stored voltage in the tube, and you go to hook up the anode first. Let's say we hook the anode up first. If there's any stored voltage in the picture tube, and you hook the anode up first, when you go to hook up your ground or touch your chassis or anything, you can get zapped a little bit. So you want to hook up the anode last and your ground first. Not necessarily first, but before the anode. So we'll hook the ground back up the way that it was. There we go. Now hook up our neck board. And last but not least, we'll hook our anode up back to our tube and see if I can show this a bit better here. So you want to hook, of course we know the anode has two little hooks right there. You want to hook one hook in and then hook the other hook in. So it's easy to just pull this and hold this back and then hook one side in and then hook the other side and make sure both sides are hooked in. And sometimes it's, there we go, got both of them hooked in. I don't know if you can see, but they're both hooked in, and make sure it's seated. There you go. So we have our anode, neck, yoke, ground. There's no remote, and we don't have power and video yet, so this is now secured and hooked back up properly and ready for testing. So let's see if I can reposition. I might have to go handheld mode here just for a moment. Actually, I'm going to cut away and get the power and video hooked up, and then we'll come back and see. Yeah, I'll probably just have the camera facing the tube and we'll just test it out. But yeah, let me do that and we'll just see how that goes. Okay, so I got power and video hooked up, but I wanted to go ahead and show here. As I was hooking this up, I thought, well, I might want to show this. So the G07 is very specific when it comes to the sync connection. For JAMA games, you have to combine the sync onto pins 2 and 3 of the sync connector there. You can see our sync connector back there has 2 wires in there, one in the pin number 2 and one in pin number 3. Pin number 1 there on that 3-pin connector is actually tied to ground. So pin 4 of the main connector there, pin 4 is ground and it's tied to pin 1 of the 3-pin. So those are tied together. So pin 2 and 3 are your 2 sync wires. And for regular standard JAMA games, you have to combine the sync into both of those pins. So you can see here I have a wire that I have both of these soldered to the sync wire, and I have both of those soldered to the sync wire so they can both feed pins 2 and 3 together. That's the only way you're going to get valid sync signal on a G07 for a standard JAMA game, which we're going to be using MK2 here. So I wanted to point that out. So let's, I have to cut away here, go turn the light out, get this turned around, get the camera on the tripod, all that. So let me get all that done and we'll come back and see how this turned out. Okay, here we are. What's going to happen? Is it going to work? Is it going to explode immediately? I don't know. It should be good. So let's find out. 1, 2, 3. Okay, comes on. Nothing has exploded yet. Don't see any smoke or anything. What's going to happen here? And it freaking works. The image is shrunk down, but that's because I moved the pots all around. So let's simply go to our, and we're way too red. That's fine. We'll fix that. Okay, not bad. Need to go into the menu. Diagnostic test, monitor patterns, crosshatch. Okay, that's what we want. Let's do, first of all, let's turn our screen pot down a bit. That's better. Okay. Now, vertical height. That pot is not scratchy at all. Works great. Our vertical position, we got to move the jumper. That's all the way down as it is. That jumper's up. That's nominal. This one, okay, that's as far down as the jumper will let the vertical go. So we're going to have to live with it the way that it is. The linearity is way off, so let's adjust vertical linearity pot to, that's pretty good. Now we can adjust our size. vertical height. That's not bad, boys and girls. That's not bad. Okay, and then our H size is pretty darn good. I might just leave it there. Look at that. I don't want, there we go. A little out of focus here. Let's see if we can get some better focus. That's pretty good. Pretty good, pretty good. We're still a little too red, but we can adjust that. Well, hot dog. Okay, let's turn our red down. I think this one's red. That's blue. That pot is scratchy for sure. Oh yeah, well, we'll clean that up. Okay. Back and forth, back and forth. There we go. Okay, a little more green. And that's pretty good there. It looks much better in person, obviously, but yep, got our red background like you should have. Boom, 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 boom. Raiden. Sorry. All right, so yeah, sorry about the refresh rate. This camera's too cheap to be able to lock it in, so if it's annoying, I'm sorry about that. But blue. There we go. Back down a bit. I think we got a winner here. Fantastic. And if we get closer, you can see it looks better. The reds are vibrant. Everything is good. It's just further back. So yeah, that's not bad there. Pretty good. It's much more purple in person. The camera doesn't really ever do these justice, but we now have a completely rebuilt, working, functional G07 with apparently no issues. So that's it. Everything turned out great. I was kind of hoping we needed to do some type of troubleshooting or something like that afterward, just to make it a bit more exciting. But it worked right out of the gate. So when you do things properly, you get a good result. So there we go. Fantastic. So, for all intents and purposes, brand spanking new G07, ready to live another 42 years, and nothing else needs done. So, hopefully you learned something. Thank you very much for watching. Make sure you like, share, and subscribe. I appreciate it. And stay tuned for more.